Okay, so if we're talking double angle identities, I'm going to write one down. Yeah, sine of 2 theta, so it's a double of the angle, right? 2, and then we put it in terms of sine and cosine to make it easier for us to solve. Okay. I'm going to show you a couple ways to use this. Okay, let's consider sine theta is 2/3. Calculate sine 2 theta. In order to calculate that, what else do we need? So if we want to do 2 theta, we have sine theta, right? What do we need to find? Cosine. We need to calculate cosine, then we plug it in, Okay, so need. Any ideas on how to find cosine theta? I've shown you how to do these. There's a couple ways. One of them's on the board. Okay, that's one. So we can use the Pythagorean identity. Right, we know that sine is 2/3, so we have 2/3 squared. Right? Two-thirds, thank you for that. I count 2 myself, but get it. Get it. Are you two going to be okay? Yeah. Because, dang. Solve the equation for cosine. That's 4/9. And I'm going to put that in terms of ninths as well so we can subtract over. And square root it. Let's add a condition to our problem here. So we're going to be in the first quadrant. Which one do we pick? Positive or negative? Why? Because everything's positive in the first quadrant. Right. Okay. So. Okay. Which quadrants are is cosine negative?
2 and 4.
2 and 3. It's to the left side of the y-axis, correct. Okay. So now we can do sine 2 theta. And just plug them in. So 2 times 2/3 times √5/3. Okay, so there's a way to use that one. You can look at the rest of them. They're the same kind of deal. Example, it's example 1. If you do B, C, and D, they all use the information from this one. Okay, they're just plug it in and do the math because they're formulas. Do you think you can handle that? Well, that's one person. Fantastic. Okay, good enough. Let's talk about half angle. Let's do cosine. Okay, yeah, they're kind of ugly. Yeah, alpha, remember that? Cosine of alpha over 2 is positive or negative root 1 plus cosine alpha over 2. The positive or negative you'll have to determine based on quadrant placement. Okay. So here's, so some of you are asking about like odd angles like 65 degrees. We don't really have a way to solve some of those with our identities so far. So, but this one can help us expand. So what about, let's say 67.5? Okay. We can use the half angle identity to solve for that. That is the same as 135 over 2, right? Cosine? So we know the value for cosine 135, correct? You can, it's right in your book there on page 305. So do I pick the positive or negative? Which one? Why? Yep. Quadrant 1, positive cosine. So it's the positive root 1 plus cosine 135 over 2, which is, oh, cosine 135. Negative root 2 over 2. Okay, these do get a little bit messy because of the fractions. Do you want me to lead you through that?
Ouch, yeah.
Ouch, yeah. Okay. Okay, so write it all as fractions. I changed the 1 to 2 over 2, so I have a common denominator on top. Combine the denominators. Now copy dot flip.
and you can square root the bottom, and you're done. Can we show you, or sorry, do you have any questions before we move on? If you,
Oh, yeah, I did.
Never mind. False alarm.
slow down the fire drill there, Batman. Well, I caught a 1960s episode of Batman on the TV when I turned it on the other day. It was that TV? We get like 3 channels over the antenna. Do you want me to show you one in radians?
No.
I'll show you the setup, then you can.
Other questions on
Okay.
that?
So, yes. This is going to be another big messy problem. Okay, there's the sine half angle identity. Yes, it has cosine in it. Let's check sine 7 pi over 12. Okay, could you do this with a sum identity? Remember the sum identities? 4 pi over 12 plus 3 pi over 12? That's a bad answer. Okay, so you could do this with a sum identity. You can also do it with a half angle. Okay, the 7 pi over 12 is 7 pi over 6 divided by 2. Okay. What quadrant? So we have to choose positive, negative again. What quadrant is that in? No. Okay. Let me give you a little reminder here. 0, pi over 2, pi, 3 pi over 2. Okay, this is 6 pi over 12, and that is, of course, 12 pi over 12. So where does it sit? It's between 6 and 12. It's in quadrant 2. So sign is positive. Okay. So if you can finish that, your money, which you should be able to because we've been working on it for a couple of weeks. Okay, I know when you guys get really quiet, it's a bad sign. What's wrong? You're not money, I guess.
Yeah.
I'm broke. Yeah, I understand. What? Which one? Oh, solving it? 7 pi over 6. Anybody know what that is? The value? It's 120 degrees, I believe. Root 3 over 2. Negative root 3 over 2. And then you're going to do your fractions again.
How do you get 4 out of the denominator?
Because I copy dot flip. So copy this, multiply by 1 over 2. And you get 4 on the bottom. Okay. Are your minds melted?
Yes.
You want me to show you an identity?
I'm not even done writing.
Verify an identity with a double or half angle.
I'm not done writing the
Yeah,
Okay.
it's kind of the central theme of this chapter.
They were writing.
Oh gosh. It's good for survival, isn't it? Do you want me to show you one? To keep working on it.
Here, we'll take the truck with us.
We'll go play Russian roulette. We'll play Russian roulette. Personally, that's basically a shadow with.
It's like playing cards with my uncle's kid. Okay, verify.
There's only one empty card for this spot. Only one empty spot to go.
You don't know what Russian roulette is?
I know what Russian roulette is.
I'm not talking to you. They are explaining it to somebody.
Cool, did you win? We don't know what Russian roulette is.
Cool, did you win?
Okay, you really have to pay attention here because I know you're still having trouble with these. What's your first instinct here?
Because my mom thought that the first time is what was to get.
Do what? Yeah, okay. So let's start by the cotangents. They're cosine over sine, right? Just, yeah. What do you think? Not yet. We don't have fractions complete top and bottom. But we need, yeah, common denominator. So cosine theta. Okay, so I'm writing this out ad nauseum, so you get it. Full dose of it. And now we can combine. That should be plus. Okay, so we needed 1 is sine over sine. They're the same thing. So I have a common denominator now. I can combine them. And now I'll let you catch up. That's so fast.
Oh, no.
You get a copy dot flip. We just make common denominators. Yeah, fractions. So what's the denominator? Sine, right? So to make this have a sine denominator, we need sine on top. Sine over sine. Right. So it's cosine minus sine on top, sine on the bottom. Right, copy that, flip that. You end up with the signs cancel out. No, those aren't squared. I know. There's a couple ways to take this one. To get to cosine 2 theta, we're going to have to multiply by okay, here's why I did that. Yeah, this is a hard one. Okay, cosine 2 theta is on the top, right? There's an identity that says that is cosine squared minus sine squared. Okay. If I multiply these two together, that's what I get. And then the bottom becomes yes, I know it's hard. Almost. And I'm going to write the identity, and sine 2 theta is 2 sine cosine, right? So I'm going to write those here. I know. Oh, quit it. Bunch of babies. Okay, the tops match, right? Can I get the bottoms to match? Okay, those do. What's cosine squared plus sine squared? It's 1. So I'm good. And we're verified because those two match. You guys are so concerned with being done. You don't even want to.
Yeah.
Yeah, I know.
I'm just
I want to let's get you working so you have some time to get help. I know. That problem number 44 has minutes in it, so I want you to change it to decimals. Because I didn't show you minutes, degrees, and seconds, or degrees, minutes, seconds. I showed you just degrees with decimals. So you can write that in your books.